Hello and welcome to the Pig Age, Teagasc pig podcast with me, Ciarán Carroll, bringing you all the latest news, information and advice to keep Irish pig farmers up to date. And for this episode, we're looking at energy use and new technologies on pig farms with Barry Caslin, energy specialist with Teagasc. And I first asked Barry to give us an overview of energy saving technologies and how farms could use them.
Pig farms are very energy intensive companies or enterprises. I know that a recent Teagasc audit on about 23 different pig farms showed a huge variation in the energy usage, and it ranged somewhere between 18 kilowatt hours per pig produced up to 45 kilowatt hours per pig produced. That would be very consistent with what I'm seeing in Northern Ireland and the UK as well, where you can have variations between 36 kilowatt hours per pig produced, maybe down to as low as 16 kilowatt hours per pig produced. So I suppose energy efficiency is very, very important, and it varies quite significantly on pig farms, as it does on poultry units as well across the country. So, and I always call it the first fuel that we need to be addressing care on farms is energy efficiency, because we can talk about putting in renewable technologies like biomass boilers to generate heat, or we can put in solar PV or solar thermal, all of these technologies. But if we can minimize the amount of solar PV that's needed, the size of the biomass boilers that's needed by being more energy efficient, that's better, because a kilowatt hour that doesn't need to be used is one that doesn't need to be produced, and it's better from a carbon footprint point of view and from the country's, I suppose, energy statistics on reducing greenhouse gas emissions as well. But I suppose the main areas that where I'm seeing it is in the farrowing unit. A lot of electricity being used on pig production units, and in the farrowing units, 95% of the energy use there will be on electricity for heating, lighting, and ventilation. Also in the weaning unit, again, heating, lighting, and ventilation. And then when you move up to the finishing units, you have ventilation and lighting. And the feeding systems that's used there, they require a lot of motive power from pumping and conveying. And then, of course, waste management, such as scrapers, pumps, again, a lot of electricity being used there as well. And there can be great variation in terms of how efficient those systems are, because there are better technologies out there today that are, I suppose, more energy efficient in terms of utilizing energy on those farms. So it's, I suppose, the main point I would give to people would be to look and monitor their energy use on the pig farms and start benchmarking what they're using, because I think energy monitoring is a key factor to successfully manage the energy use. And that's, looking at where your kilowatt hours, putting on monitoring equipment on the various technologies, see how many kilowatt hours is used for pumping, for scraping, for lighting. And that gives, I suppose, staff and people on the pig units a better idea of where the energy is being used and where it could be saved. Then after you've done your monitoring, you're looking at putting in improvements, whether it's on creep heating, whether it's on, weaner building improvements, putting in better insulation in those buildings. And there are TAMS grants available as well, I just say at the outset, for doing a lot of this, performance improvements in buildings and better technologies to improve or reduce energy wastage on these farms. Things like lighting system improvements. Again, a lot of lighting is used on pig units, and this is where savings can be maybe or adapt to more high efficient lighting systems such as LED lighting, which has come on leaps and bounds in the last 10 years and is really a very commercial technology available to people today. And of course, high efficient motors such as variable speed drives, and these can be fitted to feeding systems and to waste management systems, where the load factor on the motors is quite high.
Like it's like measuring pig production, your raw production data, pigs produced and all that kind of thing. It is essential to measure your costs, and energy now is probably one of your bigger costs after labour of the non-feed costs. So if you have your monitors and you know what your usage is, then what's the next step then in terms of, you've improved the technology in terms of creep. You might improve your creep areas, you might improve your ventilation systems or put in new insulation, things like that. What's the next step beyond that then in terms of the systems that you would use to produce heat, etc.?
Yeah, I suppose, well, in terms of heat, many people would look at, and many pig units have already changed to biomass boilers. And there's a support scheme there for renewable heat, or the SSRH, that's encouraging a lot of biomass boilers to be installed on pig units and poultry units right across the country. So what that essentially does is it's a payment system per kilowatt hour per kilowatt hour of heat that's being used on the pig unit, and you get paid for the amount of heat that's being produced from the likes of a renewable fuel such as wood chip or wood pellets, or straw could be used to heat a pig unit as well. So it's not a capital grant for those boilers, but there is it's a grant to, or it's a subvention towards the cost of energy that's being used on those farms. So the SSRH has been a game changer in terms of allowing pig units and poultry units and all businesses, these boilers can be put into hotels and hospitals and nursing homes. It's not just the agri businesses, but we're seeing a lot of biomass boilers being installed now as a result of that. And of course, the cost of biomass as a fuel compared to fossil fuel is much cheaper. If you take a comparison there, like kerosene, if you were using that as a heat method at the moment, would be costing you around 12 cents per kilowatt hour of heat, whereas you would get your pellets, your wood pellets, in the region of around maybe 5 cents per kilowatt hour. So it would be less than half the price of kerosene at the moment. So it's something that's worth considering. Then, of course, there's other technologies that would be used, such as solar PV for generating renewable electricity. So it is possible for pig farmers, obviously, have lots of roof space, and it is possible to use that roof space and to put up solar PV and generate a certain amount of your own electricity requirement rather than importing it, because the cost of imported electricity, Ciarán, at the moment is going through the roof, literally. It's this time last year we were looking at average prices of maybe less than 25 cents per kilowatt hour, and now many people are being quoted north of 40 cents per kilowatt hour, and continue to see increase in price. So it's an area that I suppose a lot of farmers need to, get a better understanding of through the energy monitoring, but then to look at how the likes of the technologies such as solar PV or wind, whatever the technology of choice would be, to generate that additional electricity that they require after they've become as efficient as they possibly can.
And I know you were heavily involved in organising the Energy and Farm Business Show, as you do every year in Gorteen College, and was most recently held there in July. And a number of pig farmers I know attended this year. And a lot of the queries I had myself, and indeed from the other advisors as well coming through, was on solar PV. So if we could just look at that specifically there for a while. In simple terms, can you tell us what exactly is solar PV, how it works, how it operates, and how farms can use that then to reduce their production costs and energy costs?
Yeah, I suppose the technology itself, it's literally, they're panels that are, they're facing south or east, and they generate electricity. They convert energy from the daylight and the sun into electricity. So it's a very well proven technology. It's been around a long time. Many people will be familiar with solar thermal, which many people got grant aid for in the past to put on maybe on their domestic houses to generate hot water. And now what solar PV is photovoltaic. It converts the energy from the daylight and the sun into electricity. So you're generating electricity. You could use that electricity, obviously, to heat an immersion. It could be like you can put a diverter onto it, and you can heat the hot water maybe in an immersion tank, and that you'd have continuous hot water, and that acts as a battery storage. So at times of the day when you're not using the full kilowatt capacity of your PV system, you have the potential of storing that excess energy rather than putting it into a battery. You have the potential of storing it as hot water in an accumulator tank and using it for your business at different times of the day or night. So as I say, it's a well-proven technology, Ciarán. It's government policy at the moment as well to electrify the heating and transport around the country. So you will see more domestic houses with heat pumps in the future, and those heat pumps will require electricity to run the compressors on them. So there will be an electric requirement. So what we're going to see in the future is houses being heated through electricity via the heat pumps. And of course, there's a major government policy as well on electrifying our transport in the future. So you will see a lot more, possibly by 2030, where you won't be able to purchase an internal combustion engine, and you will see more and more electric vehicles on the road. As a result, that will require extra electricity to run those cars as well. So electricity prices are trending upwards. These panels, they work well in Irish conditions. So they tend to clean themselves. There is a bit of maintenance with solar PV panels that they do have to be cleaned, but in Irish conditions, we don't have the dust or that you get in some other hot countries where they would be quite prominent, and they do tend to clean themselves. And like the technology, it's predictable as well in terms of the output per kilowatt installed. So it is possible to say that if you put up, on a pig unit, if you were to put up a 100 kilowatt PV array, you could be producing somewhere in the middle, in the region of maybe 93,000 kilowatt hours of daytime electricity per year. So that's a 100 kilowatt PV system. And on a pig farm, I would be expecting a 100 kilowatt system to be generally used on the farm, where you wouldn't need to be exporting it, because pig units are different to dairy farmers. Dairy farmers have this problem that they're generating the electricity during the day when the cows are out on grass and they're not milking the cows. Yes, they have a cooling requirement all right during the day, but they don't have this bell-shaped demand during the day at the milking period, and in the morning and in the evening, and then it goes back down again. And the only demand then at that stage is just for milk cooling and maybe some other maybe pumpers or scrapers that might be used. But that's a continuous, getting the base load on pig units, it's more continuous. So, and I would expect a 100 kilowatt system on a pig unit, might generate maybe 20% of the farm's annual requirement. So it'd be very, very difficult to put in a system on a pig unit that would meet 100% of the farm's requirement. But you could look at, how far you could go in terms of planning restrictions, all of that, and roof space that could determine how big you can get.
And what are the types of costs you'd expect to pay for a 100 kilowatt system, and how long is the payback period?
Yeah, well, generally it gets the bigger the system, the cheaper it would be. And like there's grant aid available there through the Pig and Poultry Investment Scheme. That's part of TAMS, and that's open to all pig farmers, who meet the eligibility criteria of TAMS. And that scheme, it offers a rate of 40% grant aid, that's available on an investment ceiling of up to 200,000 euros. And that's over the RDP period of 2014 to 2022, which has gone to now at this stage, and we'll be into a new scheme from the 1st of January of next year. There's other sources of funding available as well, Ciarán, for projects such as, including the Better Energy Communities grant aid. They'll fund maybe up to 25%. That's where maybe pig farmers could become part of a local community project, and they'd maybe get an energy master plan done for that community. And they get funded through SEAI, that's the Sustainable Energy Authority of Ireland, by becoming part of the Better Energy community in their area. And there's also what's called Exceed funding available. Exceed it's possible funding route for pig farms, and it's really based on the opportunity for further upgrades on the likes of ventilation, mixing systems, lighting systems. I suppose carbon reduction volumes are going to be a key deciding factor in those kind of applications, whether they'll be accepted or not. But again, Exceed could be, you could get potential funding of up to 40% through Exceed, again through the Sustainable Energy Authority of Ireland. But yeah, your question there in relation to the payback is and the cost, like a 100 kilowatt system could be costing maybe 90,000 euro. And generally you see most of these systems paying back in maybe about 4.5 to 7 years. But that's just that's not taking into account other advantages that are there as well. Like the VAT can be claimed back in year one, also you can get what's called accelerated capital allowances that can be, where you can write off the whole cost in 1 year as well. So when you add on, so normally capital allowances are spread out over maybe over 8 years. But in the case of energy efficient technologies and renewable technologies that are on the SEAI triple E list, these technologies do qualify for accelerated capital allowances, and it's quite an important an allowance to be available, and who knows how much longer it will be available. But certainly at the moment while it is available, and I know the pig sector has had trouble over the last couple of years, but with energy costs and with feed costs, as you mentioned at the outset there, so cash mightn't be that plentiful at the moment, but it's something to consider if things ever did improve, that if there was tax bills looming, that there would be that potential to write it off as well.
For sure, absolutely, yeah. And you mentioned briefly there planning permission. What's the latest on planning permission? Planning permission is required, but is there changes in the near future that might speed up the process, or?
Yeah, so at the moment the panels, it's a restriction, I suppose, that if you take an average size house, they would generally require in between maybe 3 to 5, maybe 6 kilowatts of solar PV array, but the planning limits on a domestic dwelling house is 12 meters square. So 12 meters square at best would get you maybe 2.5 kilowatts of PV array, so it wouldn't meet your requirements for your domestic house. And for agricultural buildings, the restriction there is 50 square meters. Now 50 square meters would get you maybe about 9 kilowatts of a PV array on an agricultural building. So again, the example I give you there, most pig farmers would probably be looking at between 50 and 100 kilowatts of PV arrays. So you are into planning territory there. There is an expectation that planning will be relaxed for developments of up to 50 kilowatts that meets the microgeneration scheme requirements. So microgeneration is this new scheme that will be allowing businesses to export excess electricity back to the grid. And hopefully in the next couple of months, we will see this open and all farmers and all businesses will be able to avail of it, where they produce excess electricity and they can export it back to the national grid and get paid per kilowatt hour of electricity that they produce. But there are the restrictions at the moment, but I would hope that 12 square meter for domestic and that 50 square meter for agricultural limit will be removed, and that we will see a more relaxed approach towards planning of projects up to 50 square meter, up to 50 kilowatts in size.
Yeah, it certainly makes sense to do something like that anyway now, in the crisis we're in at the moment, I suppose. Just onto some of the technical stuff. So how well do they work, in terms of the environment? Pig environments can be harsh. You've got high ammonia levels from time to time. Dust levels can be high from time to time. How well do the panels work? How often do they need to be cleaned? Is the casing or the mounting important in terms of weathering the dust and the ammonia, etc.?
Yeah, ammonia, you do need robust panels in the case of, and in the case of pig units where ammonia gases are going to be accumulating. And there are robust panels that can be got specifically for those type of situations. And that's where you're talking about glass at the back and glass at the front. So it's a more robust panel. Also where salt erosion may be an issue for anyone in a coastal area, they would require those type of robust panels also. Like your standard solar panels, they're also 1.6 meters or 1.66 meters by 1 meters. That's generally what they would come as, and they're 280 to 320 watts per panel. And generally the way they're designed is that there's a glass foil design. So the cells between a pane of glass, and then there's the foil laminate underneath. So in the case of these more robust ones, you have glass on the back and glass on the front between the panes of glass, then you have this foil laminate underneath. I suppose it's important to say to people as well that they do come with product warranties and performance warranties as well, Ciarán, and that generally some of them it's really an important question to ask an installer, like what is the product warranty with the technology that's being provided, and what is the performance warranty? So the performance is how long would you be expecting it to give so many kilowatt hours per kilowatt of installed capacity. So as I say, each kilowatt probably should be generating in the region of maybe, depending on what part of the country you're in, of course. So, but on average across the country, maybe around 900, maybe 850 to 900 kilowatt hours of electricity per kilowatt installed. And then there is an expected degradation on that of maybe 0.7% per year, so that each year that goes by, the efficiency or the output or the performance will go down by maybe 0.7% per year. So they're the kind of questions that you'd ask an installer. What is the expected degradation in terms of its output per year?
Very good. Yeah, so it is critically important to look for those warranties before you'd go any further in terms of your investment, and so you'd know what your typical lifespan might be before you'd have to change up. In terms of the situation in regards to supplying any excess, I know you said that in most cases you probably wouldn't have systems that would be producing too much excess that you'd need to supply, but in the case where you might, what is the story with supplying excess into the national grid? Or are you better off to look at a kind of a battery storage as an alternative to trying to connect to the grid?
Well, I suppose the jury is out with batteries at the moment, and certainly in a situation now where we do have a microgeneration support scheme, that's where you'd have to question the batteries, because you do have that ability to export it back to the national grid, and also to get paid for it. But batteries can act as a power backup, and there is a grant in TAMS as well to up to 6 kilowatt hours of battery storage. Like the batteries, they can operate in both alternating current and they can operate in direct current. So what you could have a situation where the batteries are charged by direct current by maybe surplus solar electricity during the day, and once that electricity from the battery has been discharged, you could end up recharging it on the cheaper night rate electricity for discharge in the morning if you had a peak demand at that time. So that's where batteries can be useful. But in terms of the exporting the electricity back to the grid, the microgeneration support scheme is the game changer there. So you do have the option of putting the solar PV on the roof spaces of the farm buildings, and the large scale projects. Just before I actually go into the microgeneration support scheme, the large scale projects are supported because people often get mixed up between the different types of supports. So the microgeneration is up to 50 kilowatts of PV array. And then the large scale projects, such as, where you see fields of land covered, maybe hundreds of acres or maybe 20 or 30 acres covered with solar PV panels, that's covered by the RES scheme, the Renewable Electricity Support Scheme. So we're seeing a lot of that happening across the country, where this large scale approach, and that's supported through a fairly robust scheme called the RES, which is generating a lot of interest in the last couple of years, and it's an auction process, and we're seeing wind projects and solar projects going through that. So that's 500 kilowatt plus is covered in the RES scheme, and 0 to 50 covers microgeneration. There's actually no support scheme in between 50 kilowatts and 500 kilowatts. So between the microgeneration and the RES scheme, there's no support scheme in place for that type of renewable generation. But there is a consultation out there at the moment to see what can be done in terms of introducing supports to encourage more small scale generation like that. But to answer your question there about the microgeneration and the supports that's there at the moment, there's grants there for domestic, and there's a grant of 2,400 in your own domestic dwelling house. And then you could, if you're less than 6 kilowatts, and most houses would be less than 6 kilowatt systems, they can get what's called this competitive market rate, or the CEG, Clean Export Guarantee. And that's available to all microgenerators from their suppliers. So you have the likes of Bioenergy and SSE and Electricity and Electric Ireland. They've all in the last couple of weeks raised their heads up and said, we're going to offer a certain price per kilowatt hour for electricity. And if you're buying your electricity off us, we will give you a Clean Export Guarantee of so much per kilowatt hour. So that'll be something that people could be looking at the moment, is what is your competitive market rate that you're offering me if I export excess electricity back to you? So that could be to Electric Ireland or to Bioenergy. So the funny thing about it is that the Clean Export Guarantee has gone up quite significantly over the last 12 months. It's gone. If I was speaking to you this time last year, Ciarán, I would have said the average clean export guarantee would be around 5 cents per kilowatt hour. But now it's actually gone. There's some of them offering 20 cents per kilowatt hour as a clean export guarantee. And that's just the way wholesale electricity prices have gone in the last 12 months due to geopolitical issues across Europe. So it's an interesting situation. Then for larger non-domestic businesses like farms, they can avail of what's called the clean export premium. And this is a government tariff that's available for 15 years. And this we still haven't got this introduced. Nobody's got payments on this yet, but we know what the rates are. So this is available for a 15-year period. And so every business in Ireland will be able to avail of this to export excess electricity back to the national grid at the rate of 13.5 cents per kilowatt hour. So that's any project between 6 kilowatts and 50 kilowatts in size. So anything over 50 kilowatts won't be eligible because you're out of the microgeneration territory at that stage.
That's brilliant, Barry. Appreciate that. There's an awful lot of information there. Just final one, for a farmer listening there, where can they go to find out more information on this?
Yeah, well, I suppose the most important thing that they can do is, do a bit of, work to see what is their ability, for example, to export back to the grid. Because what a lot of people might find is that they're restricted maybe due to their transformer size in their area. That could be a restriction, especially in rural areas. But I suppose, a lot of the technology providers are probably the best people to speak to, maybe in terms of, and to get different quotes from different providers. And you will learn a lot by speaking to the different technology providers as regards what each of them are saying. You can get more independent information from the likes of SEAI, the Sustainable Energy Authority of Ireland. So if you go onto their website, seai.ie, you'll find a lot of information there in relation to microgeneration. You can also Google the one-stop shops. There's a number of them have been generated across the country that provide independent information on I suppose energy efficiency, and even for upgrading your own house, to be a more energy efficient house, looking at heat pumps in your own house. The one-stop shop have engineers that provide that kind of information. And I suppose depending on what part of the country you're in, Ciarán, as well, you could liaise with your local energy agencies. So that you have Carlow Kilkenny Energy Agency, you have Tipperary Energy Agency. So it's just it depends on what part of the country you're in, you look at the energy agency in your area, and they would have engineers as well who can provide independent devices also.
That's excellent, Barry. That's a really insightful and informative half hour from you there. So appreciate that, and thanks for joining us today.
Pleasure, Ciarán. Thank you.
That's it for the latest episode of The Pig Edge, and my thanks to Barry Caslin for joining me on the show. Don't forget to tune in to The Pig Edge for all your pig production news on Apple Podcasts, Spotify, or wherever you get your podcasts. And for more farming information, go to teagasc.ie. I'm Ciarán Carroll, and thanks for listening.